Hey, welcome. This is the last in the series of three Science ACT videos. This video is Science 403. Uh, Before watching this video, I would encourage you to look at Science Video 401, just because that goes over the how-to and kind of the general framework of how to go about doing the science. This is specifically 1 out of 6 science passages will test you on competing hypotheses. So they'll present you with kind of information that's understood within the scientific community, but then you'll have different scientists or students trying to explain a certain phenomenon that occurs. So they'll say, this is what we understand to be true, but then, based off of what we already know, who can really explain the phenomenon? So like an example would be, we know that the dinosaurs went extinct 65 million years ago. Based off of that, how did they go extinct? And you'll have different scientists with different hypotheses. So let's just dig into this one. And this one tends to have, instead of 6 questions, it tends to have closer to 7 questions. And I would say normally on the other science passages, the ones that are just experiments, I say take a minute to kind of go through the tables and your variables, and then about 5 minutes to actually answer the questions. On this one, I would say take at least 2 minutes to do the reading, and then 4 minutes to answer the questions. Maybe even 3 and 3, because this one is testing you more on your ability to read and catch things than it is on your ability necessarily to process data in tables. So read and questions. Okay, so let's go right into this and figure out kind of what's the background, what's the phenomenon the scientists are trying to explain, and then how are they similar and how are they different in their explanations. Let's go with red. Okay, so introduction. Comets are complex mixtures of ice and dust that orbit the sun. They can be classified by orbital period as either long period comets or short period comets. So if it's italicized, it's key terminology that we need to know. Long period comets have orbital periods of more than 200 years. So it takes them more than 200 years to orbit their star, and originate within our solar system, so more than 200 years to orbit the sun, in the Oort cloud, a spherical shell of many icy bodies located at an average distance of 40,000 AU from the sun. AU is the distance of Earth to the sun. So these icy bodies are pretty far away from the sun. Long period comets approach the sun from all directions. Short period comets, on the other hand, have orbital periods of less than 200 years. And their orbital planes have inclinations of 30 degrees or less. So instead of coming in from all directions, they tend to only vary within 30 degrees within kind of a plane at which they orbit the sun. With respect to the ecliptic plane, the plane of Earth's orbit around the sun, portions of these planes are shown in figure 1. Okay, so they only vary in 30 degrees from kind of the plane at which Earth orbits the sun. Okay, so this is all background information. What phenomenon are these scientists trying to figure out? 2 scientists present their viewpoints about the origin of short period comets. So that's what we're trying to figure out. Let's see what scientist A says about the origin of these comets. Short period comets in our solar system originate within a thin ring-shaped region called the Kuiper belt. So that, or the KB. So within the first sentence, we already know scientist A immediately kind of gives us his hypothesis. The KB has a small inclination with respect to the ecliptic plane and is located in the solar system between 30 and 50 AU. So it's located much closer than the actual Oort cloud. The KB contains billions of icy bodies with diameters between 10 kilometers and 30 kilometers. These comet-sized objects are too small to be clearly discerned at that distance with telescopes located at Earth's surface, on Earth's surface. Such telescopes have gathered indirect evidence, but not clear images of much larger icy bodies that are part of the KB. So we not only have these small comets that are orbiting, but we also have some larger ones too. The small inclinations of short period comet orbital planes with respect to the ecliptic plane are consistent with an origin in the KB. It has been discovered that other nearby stars have similar regions of icy bodies surrounding them. Okay, let's see what scientist B says. Scientist B says the KB does not exist. Whoa, what a bombshell. Scientist A is saying these comets, short period comets, come from the KB, and scientist B is saying there's no such thing as a KB. So what does scientist B say? Short period comets were once long period comets. Some long period comets pass close enough to giant planets like Jupiter, so these gas giants, to be influenced by the gravitational fields of the giant planets and are forced into orbits with orbital planes less than 200 years. So that's how they become these short period comets. These altered orbits have orbital planes that have small inclinations with respect to the ecliptic plane. Also, most of the studied short period comets have orbital planes with small inclinations with respect to the orbital planes of the giant planets, which in turn have small inclinations with respect to the ecliptic plane. So essentially, none of these planets nor the comets vary much with the ecliptic plane. Okay, let's go to the questions. Which of the following generalizations about comets is most consistent with scientist B's viewpoint? Long period comets cannot become short period comets. No, he says quite the opposite. In the first sentence, he said his viewpoint is opposite. Short period comets cannot become long period comets. Never really talks about that. Long period comets can become short period comets. Yes, that's what his hypothesis is. No long period comets or short period comets orbit the sun. That's just ludicrous. So we're not even going to think about D there. Okay. 28. Scientist A would most likely suggest that a telescope more powerful than previous telescopes, so we're talking about scientist A, be used to search which of the following regions of space for objects in the KB. So scientist A, if you remember, does believe in the KB, and scientist A tells us that the KB is between 30 and 50 AUs. So that's where he would tell us to search, or she. So no, not that far out. This has the right area from the sun, but it says at an angle of 90 degrees with respect to the ecliptic plane. No, what all the scientists agree on is that the inclination is within 30 degrees of the ecliptic plane. So this one's going to be H, within this distance from the sun and within this angle on the ecliptic plane. Okay. 29, given the information about short period comets in the introduction, which of the following inclinations with respect to the ecliptic plane would most likely not be observed for the orbital planes of short period comets? In other words, what inclination from the ecliptic plane would we not find short period comets? And this one, we don't even need to look back. It's 45 degrees, right? Because the introduction, the information, I know I said we don't need to look back, but we are, tells us that 30 degrees within the ecliptic plane is where we find the short period comets, 30 degrees or less. And it tells us to look in the introduction, and sure enough, that's where we find it. Okay, 30. According to scientist B, which of the following planets in our solar system is most likely capable of changing the orbit of a long period comet? So if you remember, scientist B said that long period comets become short period comets when they fall within kind of the gravitational pull of kind of a large planet kind of in our outer regions of our solar system. So it's not going to be any of these because these are smaller kind of rock-based planets. So a little bit of background knowledge, but Saturn would be kind of far out enough in our solar system to, according to scientists, be and have enough of a gravitational pull to kind of pull in a comet from the Oort cloud. And if you want a way to kind of remember the planets in order, my very efficient memory just stored up 9, planets. And I know Pluto is no longer a planet, but Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So my very efficient memory just stored up 9 planets. Is a very good way. It shows you how old I am. When I went to school, this mnemonic device was still appropriate. But anyway, this will give you the order of the planets, all 8 of them and Pluto. All right, 31. Comet Halley currently has an orbital period of 76 years. According to the information provided, scientist B would most likely classify Comet Halley as, well, we know 76 years is less than orbital period of 200 years, so it's going to be a short period one. So we can get rid of C and D. So a short period comet that originated in the Oort cloud. Well, yeah, that's what scientist B says. He says that all short period comets were originally long period comets in the Oort cloud. He does not, or she does not believe in the KB. Okay. 32. Based on scientist A's viewpoint, the much larger icy bodies in the KB most likely have diameters of, and we see exact quotes, so we have to find it. So actually right here is where we have the much larger icy bodies that are part of the KB. So what we get is the KB contains billions of icy bodies with diameters between 10 kilometers and 30 kilometers. These comet-sized objects are too small to be clearly discerned at that distance with telescopes located on Earth. Such telescopes have gathered indirect evidence, but not clear images of much larger icy bodies. So these much larger icy bodies have to exceed 30 kilometers in diameter. And that's why 32 is J. Okay, 33. 33 should be challenging. It's the last one of the set. So this is a suppose most likely, which means we're going to have to make an inference. Let's see what it wants us to infer. Suppose a study of one nearby star revealed that it had no spherical shell of material similar to the Oort cloud surrounding it. How would this discovery most likely affect the scientists' viewpoints, if at all? Okay. So we have a study that says that revealed that it had no spherical shell of material similar to the Oort cloud. So essentially, it's saying that elsewhere in outer space, these Oort clouds of comets don't really exist. So what would this do? Well, scientist B says all of the material comes from way outside the solar system, way on the outskirts of our solar system in the Oort cloud, right? Our comets come from the long period in the Oort cloud and they come in. So this would definitely hurt scientist B's viewpoint. And it would hurt scientist A's viewpoint, because if you think about scientist A says it has been discovered that other nearby stars have similar regions of icy bodies surrounding them. So it would kind of discredit what scientist A has said, which is that, hey, you can trust me because essentially everything that I'm seeing within our solar system is also true for other solar systems. And this is saying actually no. So this would weaken both of their viewpoints. So it would strengthen both scientists' viewpoints, no. It would strengthen, oh, hold on. Let me think about this differently, actually. Maybe it's not weakening their viewpoints. It's not even an option. It definitely isn't strengthening. It's not weakening A's only. Let's talk about why it's D. So it would have no effect on either scientist's viewpoint. So let's think about that. So suppose a study of one nearby star revealed that it had no spherical shell of material similar to the Oort cloud surrounding it. How would this discovery most likely affect the scientists' viewpoints, if at all? Okay, so if we think about it, scientist A is saying that we don't need to worry about the Oort cloud. All of the material for short range comets comes from the Kuiper belt. So anything we observe about the lack of an Oort cloud in different solar systems doesn't affect what we know about our solar system. So it doesn't really hurt what scientist A says about the KB belt. And if we look at scientist B, uh, scientist B, none of scientist B's hypothesis is actually uh, supported or dependent upon observations from other solar systems. Scientist B never references another solar system. So actually, this one's going to be D, and I really apologize for the confusion there. But that's why this one is number 33. It requires a little more kind of layered in-depth thinking to get to the conclusion on it. And these last ones on passages, if you find that you're kind of stumbling on it or it's taking a lot of time, an easy way to save time on the science is take a moment on these last ones, but don't get bogged down forever. You can always skip it, take an educated guess, and then come back if you have time. Anyway, I hope this video is helpful, and that completes the series of the 3 ACT science videos.